Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's geometry class. Today we're going to continue in our journey of proofs, and we're going to learn about the multiplication and division properties. Okay? I want you guys to consider the several figures that I have here, two figures that I have here. If I tell you given that BC and BD are trisectors of ABE, that is the figure on the left here, okay? And then I tell you that LO and LP are trisectors of angle MLS, that would be the figure over here on the right. And I tell you if angle 1 is congruent to angle 4, then ABE would be congruent to MLS. The reason for that would be the multiplication property. So look at what we just have here. BC and BD are trisectors of ABE. So if they're trisectors of ABE, that means that angle 1 is congruent to angle 2, which is congruent to angle 3. And if LO and LP trisect angle MLS, angle 4 is congruent to angle 5 and congruent to angle 6. But if I also tell you that angle 1 is congruent to angle 4, that would mean that angle 1 here is congruent to angle 4. Then that means that ABE, this whole entire angle, is congruent to MLS, this whole entire angle. And again, the reason for that would be the multiplication property. So what does this multiplication property state? Well, if segments or angles are congruent, their like multiples are congruent. And you know that I like to translate things into numbers. Let's just for giggles say that angle ABE is 60 degrees. Okay? If I trisect that, that means that every single angle there, angle 1, 2, and 3, is going to equal 20 degrees. And if I tell you that angle MLS is also 60 degrees, when I trisect that, every angle will also be 20 degrees. So, if you have two congruent angles, and you bisect each of them, or you trisect each of them, okay, their multiples will be congruent. And that is the multiplication property. If segments or angles are congruent, then their like multiples are congruent. Let's take a look at how it works for segments. Consider the following figures. You have segment AC and you have segment XZ. If I tell you that AB is congruent to XY and B is the midpoint of AC and Y is the midpoint of XZ, what can I conclude? Yes, sir. Bless you. Okay, let's see if you're correct. I would say it in segment form instead of angle form, but yes, what you said is pretty close. If we know, okay, that AB is congruent to XY, and we know that B is the midpoint of AC, and Y is the midpoint of XY, then what I can tell you for sure is that BC must be congruent to YZ. Okay, so I wouldn't put it in angle form because we're dealing with segments here. And what would the reason be? The multiplication property. So basically what's happening here is when you have congruent angles or segments, again, their like multiples will be congruent. If AB was congruent to XY and the midpoint of AC is B, and the midpoint of Y of XZ is Y, then that means that BC has to be congruent to YZ. Okay? I'm going from a smaller part to a larger part. So that's why I use the multiplication property. Similar to the addition property. When I went from a smaller part to a larger part, that's addition. If I go from a larger part to a smaller part, that would be subtraction. And today we're going to learn how that will be division. Let's take a look at a little proof here. Given MK is congruent to FG. You know I love to label my figures. KG, though, bisects MJ and FH. So if it bisects MJ and FH, won't MK be equal to KJ? And won't FG be congruent to GH? So in essence, won't MJ be congruent to FH? Do you guys see that? Okay, so my given, and my proof, MJ will be congruent to FH because of the multiplication property. Yes, sir. You could say that KJ is congruent to GH, absolutely, but you don't need to. That would be an extra step here. What my boy was asking was, you have that MK is congruent to FG, and then you know that KG bisects MJ and FH. You could at that point say MK is congruent to KJ, and FG is congruent to GH, definition of bisector. And then you could say MJ is congruent to FH, and in this case, if you did it that way, that would be the addition property. But the multiplication property circumvents a lot of those steps. So since you know already that MK is congruent to FG, and K bisects MJ, and G bisects FH, that means the multiples of congruent segments are also congruent. So therefore, MJ will be congruent to FH due to the multiplication property. Does that answer your question, son? So you could go that route, but that route would be taking you to the addition. Okay? May I continue, gentlemen? Okay. Division property. Very similar, but the exact opposite. If segments or angles are congruent, then their like divisions are congruent. If segments or angles are congruent, then their like divisions are congruent. Division property. If segments or angles are congruent, then their like divisions are congruent. Consider the following figures, please. If GJ is congruent to LP, so we're talking GJ is congruent to LP. H and I are trisection points of GJ. M and O are trisection points of LP. So basically, if H and I are trisection points of GJ, that means that GH is congruent to HI, which is congruent to IJ. If points M and O are trisection points of LP, that means that LM is congruent to MO, which is congruent to OP. But I was given already that GJ is congruent to LP. So what can I gather from all of this? What do you guys think? Look at the figures there. Look at the markings. Yes, sir. No, we already know that GJ is congruent to LP. Yes, sir. Correct. That is exactly correct. GH will then be congruent to LM. HI will then be congruent to MO. And IJ will be congruent to OP. Okay? You would have to name everything in this particular case. Yes. Okay? Because we're trying to prove here why division property works. Yes, sir. if you went GI is congruent to LO, then that would be the addition property. Because I took these two, again, think about how we started here, guys. We started with the fact that GJ, which is the larger segment, was congruent. And then we trisected it. So when we go from larger to smaller, we're talking division. When we go from smaller to larger, we're talking multiplication. And that's exactly what the next part of this lesson tells you. How to use this, okay? Look for a double use of the word midpoint or trisect or bisect in the given information. When you see those three words doubly used in the given information, that's an indication, hey, I'm going to use the multiplication or the division property. The multiplication property, which I've already stated, but now it's in words, is used when the segments or angles in the conclusion are greater than those in the given information. And conversely, the division property is used when the segments or angles in the conclusion are smaller than those in the given information. Now, as always, the best way to really see this working is by actually completing some examples. So the good news, those are the only two properties we have to learn today. And the even better news is that now we get to practice, which I know you guys love. All right, so let's take a look at sample 1. Given NOP is congruent to RPO. You know I love to label. So NOP is congruent to RPO. PT bisects angle RPO. So that means that these two guys are congruent as well. OS bisects NOP. So that means that these two guys are congruent as well. They say that angle NSO is complementary to angle 1. So NSO, which is this angle right here, is complementary to angle 1. And they say that angle RTP, which is this guy over here, is complementary to angle 3. So those are the givens, those are the markings. They want to prove that NSO is congruent to RTP. So if you think about this here, gentlemen, we started with a larger angle and we're going to a smaller angle. So that hopefully is a little indication for you of what we have to do. So first things first, our givens. NOP is congruent to RPO. That's given. I already marked that. And actually, you know what? Let's just mark it again just to make sure you understand the flow of this proof because it's a good one. So NOP, which is a large angle, is congruent to RPO, which is a large angle. Next, PT bisects angle RPO. Okay? PT bisects angle RPO. So that means that this piece is also congruent to that piece. And that again is given. Number 3, OS bisects N. Oh, I went the wrong way. Sorry. RPO is over here. Sorry. Mr. Morrow, pay attention. And then we have now that OS bisects NOP. Sorry, I looked at the wrong angle. Sorry. Same thing, same markings. I just messed up. I got to pay attention. You with me so far here, gentlemen? Okay. So now, number 4, angle 1 must be congruent to angle 3. Why would we say that angle 1 would be congruent to angle 3? Yes, sir? Think about it, guys. I went from a larger angle to a smaller angle. No. Think. What are we talking about today? Are we talking about subtraction property? No. We're talking about division property. halves of congruent angles are congruent. Let's go back to the hint that I gave you at the beginning. You had a large angle, okay? And that large angle was bisected here, guys. It was bisected. Didn't I have a double use of the word bisected? Guys, did I have a double use of the word bisected? So that's an indication that, hey, I'm using multiplication or division. Didn't I go from a larger angle to two smaller angles? Yes. So angle 1 has to be congruent to angle 3 because of the division property. Now, some of you may be thinking, whoa, hold on. Couldn't we have said that NOS is congruent to SOP and then RPT is congruent to TPO because of a definition of bisector? Yes, but you're going way too far at that point. The whole point of this property is to shorten things up. So since you had two large angles, let's say that NOP was 100 and RPO was 100. If I bisected both of those angles, aren't they each going to be 50 now? The division of them? So that's why I have that angle 1 is congruent to angle 3 because halves of congruent angles are congruent. I can put, if you'd like, division property. I will accept that. Okay, I'm not here to make your life miserable. Step 5 and 6 are going to be the givens that NSO, and that RTP are complementary to angle 1 and 3. That's my next givens. And if I know that NSO is complementary to angle 1, and I know that RTP is complementary to angle 3, and I already proved that angle 1 is congruent to 3, how can I prove the actual proof that NSO is congruent to RTP? Yes, sir. That's exactly phenomenal. Complements of congruent angles are congruent. Do you guys see this? I see a lot of wide eyes, and that's why I'm here to help. Yes, sir.
What if we had put step 4 and step 6?
Okay, well, what would have happened if you would have listed step 4 at step 6 and listed the givens first? Okay, we've been through this already. You can list all the givens if you like. My brain, though, needs to see the sequence. Me, particular. So when I saw that OS bisected NOP and PT bisected RPO, I immediately thought, well, wait a second. I have two large congruent angles, and they were both cut in half. Well, that means that their pieces have to be equal. So then I knew, okay, angle 1 is congruent to angle 3. But the question you're asking, yes, you could put all the givens, but just be careful with that, son. Be careful. Yes, sir. No, I know what you were thinking. Again, I'm not judging you. I'm telling you how my brain works, okay? If your brain works a little bit differently, and you guys like to put all the givens first, as long as you can get to the same rationale, I'm not gonna mark that off. So thank you so much. Does that given make sense, gentlemen? You promise? Okay. Let us continue, please. Example 2. ABC is congruent to ADC. ABC is congruent to ADC. So I have ABC, large angle, guys, is congruent to ADC. Large angle, guys. Okay? That's going to be my first given. Next, BE and BF trisect ABC. So just think about this. You now know that angle 1 and angle 2 and angle 3 have to be congruent. They have to be. So that would be my second given. Step 3. You know that DE and DF trisect angle ADC. So that means that angle 4 has to be congruent to angle 5, which has to be congruent to angle 6. Okay, so that's my next given. The DE, you see, I went too far. Did I? Oh, because I forgot. Okay, I forgot a given. That is my bad. I should have put as well. Let's see if I could do this. See if I can do this here. Let me clone this. And then let me bring this here as well. Okay. So step 2 should have been DE and DF trisect ADC, and BE and BF trisect ABC. That's given and given. From there, I know that angle 2 must be congruent to angle 5, and angle 3 must be congruent to angle 6. Why? Division property. Again, I went from a large angle to a small angle. And then I'm trying to prove that angle EDC is congruent to EBC. Well, I already proved that angle 2 is congruent to angle 5 and angle 3 is congruent to angle 6 because of division property. So now, how can I prove that these two guys are congruent to these two guys? Absolutely. Well done. Addition property. And that is why I never mentioned angle 1 and 4. Because the proof that I'm trying to prove here includes angle 2 and 3 and 5 and 6, not angle 1 and 4. If you had put in your proof in step 3, that angle 1 is congruent to angle 4, angle 2 is congruent to angle 5, angle 3 is congruent to angle 6, I would have accepted that. But you don't need to prove that, because we're trying to prove that EDC is congruent to EBC. So again, why did I use division? Because I went from a larger angle, which was ABC and ADC, to smaller angles, EDC and EBC. Just making sense, gentlemen. Questions? Yes, sir. Of course, son. What's up, my brother? So as you can see, guys, we're starting to combine a lot of theorems. We already used complements of congruent angles are congruent, and this one we use division property and addition property. That's the beauty of proofs. There's a lot of stuff going on here. May I continue, brothers? Yes? Well then, perfection. We're golden. Any questions at all? Thank you very much. I hope you learned a lot and have a wonderful day.